With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with the question which says there are two plano-convex lenses, each of focal length 10 cm and having refractive index as 3 by 2, are placed as shown in the figure. In the space left, water of refractive index 4 by 3 is filled. The whole arrangement is in air. The optical power of the system is in depth rays. So we have to calculate the optical power. So for optical power we can write P is equals to 1 over F. Alright, so here we have to be careful that F, that is focal length, has to be in meters so that the power comes out in diopters. Alright, so first let's try to calculate the value of focal length. Here also one more thing we have to understand here over is, so this is the case of combination of lenses. Here we can see this is one lens, this is two lens, that is two plano-convex lens, and in between a liquid is been filled, that has been given in the question. So this will be the liquid filled will behave as if it is a concave lens, and this, let's consider it to be as the third lens over here. So let's say this is our equation number 1. So this equation will slightly get modified and we can write P, that is power, total power we can say, or power equivalent we can say, will be nothing but 1 over F equivalent. Alright, so we have to first calculate the result for 1 over F equivalent. So for that we will take these three cases, and let's suppose that power for first lens, plano-convex lens, is 1 over F1, second it is 1 over F2, plus third it is 1 over F3. Alright, and this will give us a value of 1 over F equivalent. So now let's proceed and take each lens one by one, and we will try to get the answer to the question. So for the first plano-convex lens, we can see we can apply by Lensmaker formula. By Lensmaker formula we can say 1 over F1 will be nothing but, the formula goes like, first it is refractive index of lens, that is 3 by 2, upon refractive index of medium. Medium is being given as air, so it will be taken as 1 minus 1, and here it would be 1 over R1, that is first reflecting surface. So if light rays travel from this side, so this will be the first reflecting surface, and since it is a plane surface, so its radius will be infinity. So we can take 1 over infinity minus of 1 over, if let's suppose that radius of this surface is R, so we can say it has to be minus of R. Why we are taking it as to be minus? Because we know every distance is measured in the measured from the optical center, and we know optical center will be lying somewhere over here. So we can say and we know the distance measured in the direction opposite to that of the incident light will be taken as negative. So this has taken as negative. Just we have to follow the conventions. So from here we can say this can be written as focal length is been given as 10, so 1 over 10, and that is equals to 0.5 by R. Therefore from here we can say the value of R can be written as 5 centimeter. Alright, so this is, from here we have calculated the value of R, so this is centimeter, so we have to be okay. Now let's move on to the second part, that is we will take another plano-convex lens, so it will also give the same result. So let's try find the value of 1 over F for third lens, that is for concave lens. So we can write 1 over, now 1 over F3 would be equals to refractive index of the lens, that is been given to be as 4 by 3 we have to take, because here we can see refractive index of the water is given as 4 by 3, which is nothing but it is acting as a concave lens, so we will take it as to be 4 by 3, and since it plays in the medium of air, so here it is 1 and minus 1 into here we can write 1 over minus of 5 minus, here we can write it as 5. So we can visualize it. Let's suppose that, let's try to visualize this condition over here. This is our second refracting surface, as both are having radius of r, so we can just have to follow the convention. This first refracting surface is measured in the direction opposite to that of incident light, and this the radius of this second refracting surface is measured in the direction of the incident light, so it has to be taken as positive, and here it is taken as negative. So from here we can say this can be written as 4 by 3 minus 1, that is 1 by 3 into this can be written as minus of 2 by 5, or which is minus 2 by 15 centimeter. So this is the value of F3 we have calculated. So now what we can do over here is we have calculated F1, F2 and F3. Now we can calculate 1 over F equivalent. So for that we can write now 1 over F equivalent would be nothing but, we can write it as 2 by F1, that is, since we know 1 over F2, let's write it only 1 over F1 plus of 1 over F2 plus of 1 over F3. Alright, so from here if we substitute the value 1 over F1, we have calculated it. F1 is 1 over 10, 1 over F2 is also 1 over 10, plus of 1 over F3 we have just calculated it as minus 2 by 15. So 1 over F equivalent would be nothing but 2 by 10, that is 1 by 5 minus of 2 by 15, or this can be written as 1 by 15. So from here the value of F equivalent can be written as 15 centimeter. Alright, now we can use the above equation. Therefore P equivalent will be nothing but 1 over F equivalent, and here if we substitute the value, it is 1 by 15, and we have to convert it into meters, so 10 raised to minus 2 we have to multiply it, and this gives us the answer as 100 by 15, and that is equals to 6.67. Alright, dioptre. So here this can be written as 100 by 15, and this gives us the answer as 6.67 diopters. So this is the answer to this question, and this matches with option A. So I hope you have understood the concept well, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.